So my group's doing question number 5, and I'll be doing part A. So part A is asking, find the x-coordinate of each relative minimum of f on the interval -2 to 3. Then justify your answer. So we have to find a relative minimum. But before we can even find a minimum, we have to find the critical points. So we know there's a critical point whenever f prime of x is equal to 0. So if we use the chart they've given to us, we see that there's 2 points where f prime of x is equal to 0. That's right here and right here at -1, at x equals -1 and x equals 1. So we know there's critical points at x equals -1 and x equals 1. So then we can move on to the minimum part. So since we need to find the x-coordinate of each relative minimum, we know that our f of x needs to change from negative to positive. So if we go back to the graph, we see we can check the points. So the first critical value was x equals -1. So if we look at x equals f prime of x equals -1, we see that this is equal to 0. And when it keeps going, it stays from a negative, and it's still a negative as it keeps moving. But then if we look at 1, we see that it starts out as a negative, but then goes to become a positive. So because it's like that, we understand that f will have a minimum value because f prime of x changed from a negative value to a positive value. So to justify that, we can write on the interval -2 to 3, f has a relative minimum at the point x equals 1 because f prime of x changes from a negative to a positive value.
This is 5b, which is asking to explain why there must be a value for c on the interval of -1 to 1, such that f double prime of some value c equals 0. So to justify this statement, we're going to use the mean value theorem, which states that if a function f of x is differentiable and continuous on an interval, so in this case -1 to 1, then the derivative of that, so f prime, the derivative of that with some value c will equal f of b, so on our interval, so f of 1 minus f of -1 over b minus a, which would be 1 minus -1. And so this would be a definition for if we wanted to justify that f prime of c equals 0, but it's asking for f double prime of c. And this still works because in the question it states that f of x is twice differentiable, which means that not only is f of x differentiable and continuous, but f prime of x is differentiable and continuous. So we can rewrite this as f double prime of c equals f prime of 1 minus f of -1, f prime of -1 over 1 minus -1. And if we plug in values here, we get 0 minus 0 over 2, which equals 0.
Okay, so I had problem 3, or part C, and it says the function h is defined by h of x equals the natural log of f of x. Find h prime of 3. Show computations that led to your answer. So first we have part C, and h of x is equal to the natural log of f of x. So what we need to do is we need to find the derivative. So the derivative of this function is, well, we need to use the chain rule. So the derivative of the outside function is 1 over f of x. Now the derivative of the inside function, which is f of x, is f prime of x. So using the chain rule, we find the derivative. Now we need to plug in 3, and you get 1 over f of 3 times f prime of 3, and then you get f of 3 is equal to 7. So 1 over 7 times f prime of 3, which is equal to 1/2. So you get 1/7 times 1/2. You get 1 over 14. And h prime of 3 is equal to 1 over 14.
So question number 5 is asking us to evaluate this integral. So the integral from -2 to 3 of f prime of g of x times g prime of x dx. So whenever we have one equation times another equation, you have to use u substitution. So that's what we're going to do first. So we're going to have the u equal g of x. And then that means du over dx is going to equal g prime of x because that's the derivative. And then if we just multiply by dx, then you get your dx value is going to equal du over g prime of x. Okay, from here we can start, we can substitute this back into the equation. So the integral from -2 to 3 of f of u, because our gx is our u value, multiplied by g prime of x. And then our dx is du over g prime of x. Now we did this right because these two can cancel out. So after they cancel out, we're left with the integral from -2 to 3 of f prime of u du. Okay, now you just have to get the antiderivative. So for this, the antiderivative of f prime of u is just f of u. And then we need to find that from -2 to 3. So after substituting it back in, substituting our u value, g, we get f of g of x. So now we need to use the fundamental theorem of calculus to figure out what our actual value is. So the fundamental theorem is just f of b minus f of a. So all we have to do is plug that in. So f of g of 3 minus f g of -2. Okay, now all we have to do is evaluate. So we need our g of 3 value and g of -2 value. So g of 3, we see that that is just 1, and then our g of -2, that's -1. So we just have to plug it in. So f of 1 minus f of -1. And again, we just go to the chart again, and then f of 1 and f of -1. So f of 1 is 2, and f of -1 is 8. So 2 minus 8. And then we just evaluate that. That's -6, and that's the answer.